In this video, we'll be looking at our 7-11 math review. I'm looking at day 1. These are our problems for Monday. We're converting between fraction, decimal, and percent. Well, hopefully you remember from earlier discussion that percent means per 100. Percent means per 100. It'll be very helpful for our conversions here. So let's say we have 20%. To make 20% into a fraction, we will simply recall that percent means per 100. So 20% is equivalent to 20 per 100. The divide bar in a fraction we can read as per. 20% is equal to 20 divided by 100. Well, we can reduce this 20 over 100. 20 goes into 20 one time, 20 into 100 5 times. So 20% is equal to 20 over 100, and that's also equal to 1/5. How do we convert that to a decimal? Well, in the case that our denominator is 100, we can simply write the numerator with 2 decimal places, or we also may know that to convert from a percent to a decimal, we simply move the decimal 2 times to the left. 20% is equal to 0.20. We don't need this extra 0 here. We could write it as simply 0.2. So 20% is equal to 0.2. It's equal to 0.20. It's equal to 20 over 100 and 1/5. All of these are equivalent ways to write 20%. Okay, let's look at converting a fraction to a percent. Here we have 1/20. This is our fraction. I want to make it a percent. Again, I know that percent means per 100, so I'm going to employ a proportion to do this conversion. I'm going to set 1 over 20 equal to x over 100. We know that percent means per 100. I simply want to know what fraction with a denominator of 100 is 1/20 equal to. Well, we could cross multiply. We've seen that previously. Or in this case, the easiest way is to imagine what number would I multiply 20 by to get to 100? Well, 20 times 5. 20 times 5 yields 100, so I'll multiply 1 by that same amount. Here, 1 times 5. That is equal to 5. In this case, x is 5. That is 5 over 100. So, since this 1 over 20 is also equal to 5 over 100, I know that the equivalent percent is 5%, because percent means per 100. We can likewise convert this to a decimal. 5% moving my decimal over 2 places is 0.05. Often we say this is 5 cents. 5% is like 5 cents. With that information, you should be able to complete the chart. Now going down to our percent problems. We have 1, 2, 3, 4, 5 of them down here. I'm going to do a couple with y'all. I'm looking at what percent of 80 is 35. What percent? In this case, we're looking for the percent. What percent of 80 is 35? Well, we've talked about a couple of different ways to solve this. First, we can write this as a fraction. We know of indicates the whole. Of indicates our whole or total. Is 35, this is our part. So I can write 35 out of 80. 35 of 80. I want to know what is the percent that this is equivalent to. Just as we said before, percent means per 100. So 35 over 80 is equal to x over 100. In this case, we're going to cross multiply and solve for this x. First, let's see if we can do any reducing. 35 and 80, 5 goes into both of those. 5 goes into 35 7 times. 5 goes into 80 16 times. Now I can do my cross multiplication. 7 times 100 is 700. 16 times x is 16x. So I have 16x is equal to 700. Now, solving for x, we will divide by 16 on both sides. X is going to be 700 divided by 16. I will leave that for you to do. Okay, going now to day 2. Three and 1/4 times 5 and 3/5. Well, I'm going to convert both of these mixed numbers into improper fractions. 3 and 1/4, 3 times 4 is 12, plus 1 is 13. 3 and 1/4 is equal to 13 over 4, times 5 and 3/5. 5 times 5 is 25, plus 3 is 28 over 5. Well, when we're multiplying fractions, it's much easier than adding and subtracting. We simply multiply straight across. First, if there's any cancellation we can do with any denominator and any numerator, we do so. For instance, 4 and 28. 4 goes into 4 one time, 4 goes into 28 7 times. This will make our multiplication a little easier. Multiplying straight across. 13 times 7 is 91. 1 times 5 is 5. We have 91 divided by 5. Well, we want to reduce this. We want to know how many times does 5 go to 91? Coming down for scratch work here. 5 into 91. 5 goes into 9 one time. 1 times 5, 5. Subtracting. Bringing down by 1. 5 into 41, 8 times. 8 times 5 is 40. Subtracting. Well, this 1 I can write as a remainder over this 5, my divisor. Rewrite this as 18. 18 and 1/5. That is my quotient, 18 and 1/5. Before I leave, I want to check for reasonableness. 3 1/4, 5 and 3/5. Well, let's for 1 second just don't worry about the fractional parts. What is 3 times 5? Well, it's 15. So clearly our result should be more than 15. Let's increase these two numbers. Let's look at the top end. So I'll make 3, 4, and I'll make 5, 6. What's 4 times 6? 24. Well, clearly our result should be less than 24. It should be more than 15, less than 24. This result is indeed reasonable. All right, now we'll do one division problem. I have 1 5/8 times 4 over 1. Again, changing 1 5/8 from a mixed number to improper fraction. 1 times 8 is 8, plus 5 is 13. 13 over 8. Divided by 4 we can write as 4 over 1. Well, you may remember when we're doing division of fractions, we multiply by the reciprocal. That is, we keep the first one. We change our divide to a multiply, and we flip the second fraction. 13/8 divided by 4 over 1 is the same as 13/8 times 1/4. Now, just like before, we can multiply straight across. 13 times 1 is 13. 8 times 4 is 32. 13 over 32 is less than 1. It's pretty close to 1/2. 16 over 32 would be 1/2. 1 5/8 is close to 2. 2 divided by 4 is 1/2. So this number, 13 over 32, appears reasonable. All right. Find the constant of proportionality. Express it as y equals k times x. Well, we want to find what the multiplier is that gets us from our x to our y. In this case, we see 8 goes to 344, 3 to 129, 7 to 301, 9 to 287, 2 to 86. What number are we multiplying by to get from x to y? Well, we can simply find that by dividing y by x. If I were to solve for k here, I would divide by x on both sides. The x cancels with the x to leave the k, so we see that this equation can be written as k equals y divided by x. So, in order to find this value k, we simply divide any of these y's by x's. Dividing 86 by 2 yields us 43. In this case, k equals 43. That is our constant of proportionality, and that is the number that would go in this blank. What we're saying is, to get from any of these values to these values, we simply multiply by 43. I will show in this first cell. 8 times 43, hopefully, will be 344. So, 43 times 8. We hope that yields 344. 8 times 3 is 24. Carry my 2. 8 times 4, 32, plus 2, boom, 34. This value k is what we multiply by to get from the x's to the y's. You can use that same method to find k on 2, 3, and 4. All right, lastly, we have some adding and subtracting of integers. Well, hopefully we remember our two rules for adding integers. Adding integers. All right, number 1, when the signs are same, we add and keep the sign. Two, when the signs are different, we subtract and use the sign of bigger number. I'm putting this in quotation marks. Really, we mean the larger absolute value. But we're going to use the number that has the greater absolute value. Let's look at an example. I'm looking at this one, 6 plus negative 7. We can see that we have an addition, and we can also see that the signs are different. When the signs are different, we subtract. That is, what is 7 minus 6? Well, 7 minus 6 is 1. Use the sign of the bigger number. That is, do we have more negatives or positives here? There is one more negative than positive, so our result needs to be negative 1. Okay. Contrast that to this one, negative 6 plus 9. The signs are different, so we will again subtract these numbers. Negating the sign, 9 minus 6 is 3. In this case, we have more positives than negatives, so our result is a positive 9. Looking at this one, negative 10 plus negative 3. In this case, the signs are the same. When the signs are the same, we add and keep the sign. That is 10 negatives and 3 negatives. Well, that's obviously 13 negatives. What do we do when we have a subtraction in between? Well, you may remember we're going to keep, change. Keep the first number the same, negative 12. Change our subtraction to an addition, and then change the sign of the number following the subtraction. So negative 12 minus negative 9 is the same as negative 12 plus 9. Then you can employ the two rules here. All right, use that information and work the rest of those problems. So then you're going to come up